Hello, Math CEO mentors. Today we are going to be taking a look at meeting number 8, which is radar charts. So, for this meeting, the purpose of this meeting is to appreciate the life stories of peers, mentors, and students included, ask questions to find out more about each other, and praise each other's journeys, whether that be from a cultural standpoint, from an educational standpoint, or whatever it may be, and accept each other's differences, as should always be a goal in Math CEO, and encourage people to be kind or good people. For the warm-up, we will ask the students about the ways they like to get around. For example, you could say, who here likes to scooter? And then you might have a few hands raised at your table. You could also ask, who likes to rollerblade? A lot of students find this very fascinating as it's a little more unique. And some students may be like, ooh, I really like that. So ask some questions to prompt some students to get engaged in a sort of way. Before we get into the actual activity, have the students look at the radar charts for the methods of transportation. More on this in a few. We will be looking at an example of the sidewalk surfer, which is a type of scooter, and the street flyer. You'll have the students compare these charts for the two vehicles. When one category is higher than the other, what does it mean for the other categories? These are the types of questions we want to be asking. Then we will use the scale rings, more on this in person, to determine the style scores for both vehicles. So here are the examples of the radar charts. The first one we will look at over here is the sidewalk surfer, aka a pro scooter. Now, we can see from our radar chart, portability is at a 9. That means it's very portable. It's easy to fold it up and take it with you somewhere. It's easy to bring around. Style, yeah, it looks pretty cool. We'll go ahead and give that one an 8. So as you can see, safety is a 5. Not going to be as safe because there's kind of low protection on this. You're very exposed, some would say. Speed, a 4. Yes, the scooter can go fast, but at the end of the day, is it anywhere near a car or a plane? No. So we're going to give that one a 4. And then you can see if you plot these points and draw the lines kind of outwardly, like a circle-ish, you get this chart. And then you shade that in, and that's the radar chart. Really quickly, let's see what this adds up to. We have 8 plus 9 plus 5 plus 4. It's 26. Keep that in mind. Now let's look at the street flyer, aka bike. Similarly, we designate the categories all around. As we can see, it creates this looking radar chart, which we shade in and connect with our rounded lines. And let's see what this adds up to. 6 plus 3 plus 9 plus 7. 25, right? Let's check. 9 plus 7 is 16, plus 3 is 19, plus 6 is 25. So we can see that one of these adds up to more than the other, which is okay for now. Right now, we're just getting a feel of what these charts look like and how to read them. Moving on, we have the 28-point challenge. In this, students will have the opportunity to make their own method of transportation, which gives them a little bit of creative liberty, which is always very fun in Math CEO. There are only two requirements. The first one is there have to be 4 categories. The second one, this time, as we didn't see in the previous example, this time it has to add up to exactly 28 points total. Mentors, your job is to have the students analyze the variance. What this means is how much do the point values differ from one another on the radar sheet and from team to team. So for example, let's look at these two. You see these values are all pretty scattered. Speed and safety, though, are very similar for the scooter, and style and probability are pretty similar. So the variance, quite a lot, but when you look at only 2 categories, maybe not so much. Similarly, for the bike, 6, 7, and 9 are all pretty close. So that's not too much variance up there, but the portability is only a 3. So there is quite a lot of variance here. And then we also want to look at the variance between the two. How different are the numbers? We see the only number these two share are 9. But while the bike has 6 and 7 and the scooter has 8, those are also, or sorry, 8 and 5. Those are also a little close, but still quite a lot of variance. The next thing we want to look at are the weights. Which two categories seem to be the most important? Looking back at this example, we see overall the highest category is either style or safety. These aren't two good examples of weights to look at, but when the students create their own, they might all want to be going really fast or whatnot, so that might be a little more important to them. Here's an example I did. So the students will be creating their own vehicles, and again, the two rules are that there are four categories: speed, safety, portability, and style, and then they add to 28. For my vehicle, I decided I wanted to be fast and stylish. So I got to 16 points there, both of those having 8. Now, portability, I also want to be able to take it places with me. So I don't want to just have this really cool looking vehicle and fast vehicle, but just not be able to bring it places. So I decided to give the portability a 7. So it's still fairly high. Now, because I did that, we see I have 8 plus 8 is 16, plus 7 is 23. To get to 28, I only have 5 more points, which means I better be careful on my scooter or on my whatever vehicle it is I'm riding because that's only a 5. So I got to make sure to watch out for that. So in short, you will be having the students work in teams, have some fun with this activity. It's not too math related right now. We're just getting the students to interact with each other and collaborate and create fun little vehicles and share stories about maybe what they used to get around when they were kids. As always, good luck and have fun.